So, now here loss of energy on sharing charges. As we have seen, the concept of common potential, sharing of charges takes place. During this process, some energy is lost in the form of the electromagnetic radiation. We can calculate this loss of energy. Suppose initial energy of each capacitor having capacitance C1 and C2. Here its initial energy is E1 is equal to half C1 V1 square, and its energy is here E2 is equal to half C2 V2 square. So, total initial energy we can write E is equal to half C1 V1 square plus half C2 V2 square, and total final energy we can write EF is equal to here half C1 plus C2 into V square, where V is here common potential. So, now we can get the loss in energy, that is EI minus EF is equal to half C1 V1 square plus half C2 V2 square minus, here we can take half C1 plus C2 into V square. Now, we have to replace the value of V, that is called here common potential. So, when we replace the value of V, so we can get this expression E is equal to, that is a loss in energy, we can write EI minus EF is equal to half, we can take common here C1 V1 square plus C2 V2 square plus here this one the minus C1 plus C2 into V square can be written C1 V1 plus C2 V2 upon C1 plus C2 whole square, like this. This expression is coming here in this way. Now, we can solve it. So, when we simplify it, this C1 plus C2 will get cancelled here with this one step here. So, we will be getting, let it be like this is only here now in the first stage C1 plus C2. Now, we can write half C1 V1 square plus C2 V2 square minus, here I can break this according to A plus B whole square. So, we will be getting here C1 square V1 square plus C2 square V2 square plus twice of C1 C2 V1 V2 upon C1 plus C2, this one. Now, we can take LCM and solve it. Half, here when we take the LCM is here C1 square V1 square C1 C2 V1 square plus C1 C2 V2 square plus here C2 square V2 square minus here C1 square V1 square plus, so that will be coming here the minus C2 square V2 square minus twice of C1 C2 V1 V2, and this whole divided by C1 plus C2. So, now many things will get cancelled over here. So, we can cancel this one, we can cancel here also this one and this one. So, we will be getting this term and this term, where we can take common C1 C2. So, we can write half C1 C2 V1 square, here downside C1 plus C2 also, V1 square, here this is here the V1 square plus V2 square minus twice of V1 V2. So, this is here the loss of energy here. We can also calculate simplify it half C1 C2 V1 minus V2 whole square upon C1 plus C2. So, now we can see in this step here this value is positive, obviously EI is greater than EF. So, during the sharing of the charges loss of energy takes place, and this loss of energy can be calculated by this formula.